ఏ రోజు నా రోజు రిపోర్ట్ రికార్డ్ చేయాలి రికార్డ్.
అయితే సార్ రఘు సార్ కూడా జాయిన్ అయ్యారు.
हेलो हेलो.
హలో రఘు సార్, దిస్ ఇస్ సాయి చందర్ సార్.
Yes, sir. Can you hear me, sir?
ఎస్ సార్, యూఆర్ ఆడియబుల్ సార్, యూఆర్ ఆడియబుల్.
Okay.
Right after the introduction, we'll make you as a host to share your slides.
Okay, sir.
Okay, right.
Just a minute, sir. I think. Hello.
Tell me,
Hello.
sir. Sir, tell me, sir, you're audible.
Your voice is too low, sir. Is it my voice is clear?
Yes, sir, your voice is clear, sir.
Okay.
ओ मेरा भी मनन यादव आ रहा है। मैंने तो देखा ही नहीं, अभी फिर से करना पड़ेगा कुछ तो। मनन मतलब मेरे बेटे का नाम है।
they will find three dots.
अरे भाई माइ क्या आज सबका उल्टा आ रहा है, मेरा भी गौरव आ रहा है।
Shiva sir, Sai sir, am I audible?
Yes, sir.
You are audible, sir. Audible.
Is it clear
Sir.
everything, guys?
मेरा भी मन नहीं
Yes,
आता।
sir.
Raghu sir, good afternoon, sir.
Good afternoon, sir.
Shiva sir, కొంచెం participants కి మ్యూట్ చేయరా అందరికి?
Shiva sir. Sir, Raghu sir unmute చేయాలి sir. Raghu sir, Saida sir, నేను. Only 3 members should be unmuted and remaining all will be muted.
भाई क्या आज सबका उल्टा आ रहा है, मेरा भी गौरव आ रहा है।
Shiva sir, Sai sir, am I audible?
Yes, sir.
You are audible, sir.
Is it clear everything, guys?
मेरा भी मन
Hello, Sai sir.
Sir, tell me, sir.
నసర్ సార్ జాయిన్ అయ్యారు, ప్రిన్సిపల్ సార్ కూడా జాయిన్ అవుతున్నారు.
Okay, sir.
2 minutes మీరు స్టార్ట్ చేయండి.
Okay, sir. Right. Raghu sir, Saida sir, నేను.
Sir, వాళ్ళు అన్మ్యూట్ చేసుకోవచ్చు సార్, అన్మ్యూట్ అవుతారు సార్.
Unmuted and remaining all will be muted.
శివ సార్, శివ సార్ బ్యాక్గ్రౌండ్ సెట్ చేయండి ఇది. Sai sir, you can start, I think so.
Okay, sir.
సార్ వచ్చారా? ప్రిన్సిపల్ సార్ చూడండి ఒకసారి.
No, sir. Sir, I'll start the session, sir. Sir, very warm good
వచ్చారు, సార్ వచ్చారు.
Good afternoon to one and all. The theme of this FGP revolves around the fostering innovation and bridging the gap between theoretical knowledge and practical implementation in IoT and embedded systems. It aims to equip with hands-on skills and advanced methodologies, empowering them to seamlessly integrating cutting edge of IoT and embedded technologies into their academic and professional pursuits. Participants will explore innovative approaches to enhance system design, optimize applications, and drive impactful solutions in real-world scenarios. The KG Reddy College of Engineering and Technology was established in the year 2008. It is a private self-financing technical institute approved by AICTE New Delhi, affiliated to Jawaharlal Nehru Technological University, Hyderabad. KG Reddy College of Engineering and Technology has got a UGC status in the academic year 2021 and 2022. NBA accredited to CSC and ECE department. KG Reddy College of Engineering and Technology's sole purpose is to create next generation of engineers who are permitted to succeed in the time of constant flux by offering globally lauded teaching and learning methodologies, supported by state-of-art infrastructure and facilities. KGRTech has been consistently giving rise to a new wave of over a decade. All stakeholders at KG Reddy College of Engineering and Technology collectively work together, achieving the vision and mission of the institute. Now I take the immense pleasure of inviting our head of the Department of Electronics and Communication, Angoti Saida sir, to deliver his speech.
Yeah, thank you, Sai sir. Am I audible? Hello, Sai sir.
Yes, sir, you can.
Professor
Yeah,
Saida,
yeah.
you're audible.
Thank you, sir. Thank you, Sai sir. Respected faculty members, scholars, and participants, Principal sir and Dean Academic sir. It gives me immense pleasure to welcome you all to the national level faculty development program on the theme of innovative approaches in IoT and embedded system, hands-on approaches to bridging theory and practice. This FDP is scheduled from 6th January to 10th January 2025. In era where the Internet of Things and embedded systems are revolutioning industries and everyday life, it is imperative that we as educators, researchers, equip ourselves with innovative methodologies and practical insights. This FDP aims to bridge the gap between theoretical concepts and real-world applications by focusing on hands-on approaches and cutting-edge technologies. This FDP will serve as a platform to explore new pedagogical tools, share knowledge, and engage in meaningful discussion with subject matter experts from academia and industry. Over the course of these 5 days, you will have the opportunity to participate in interactive sessions, live demonstrations, and collaborative learning activities that will empower you to implement these approaches in your teaching and research. I extend my heartfelt gratitude to the organizing committee, speakers, and participants for their contribution and enthusiasm in making this program a success. I am confident that this FDP will be a transformative experience for all of us, fostering innovation and excellence in our respective fields. Let us make this most of this opportunity to learn, grow, and contribute to the advancement of technologies and education. I wish you all the enriching and productive learning journey. Thank you all. Thank you all. Thank you, Sai sir.
Thank you, sir. Sir, now I request Sai Satyanarayana Reddy sir, Principal of KG Reddy College of Engineering and Technology, to address the speech or to address the gathering during the 5-day FDP organized by Department of Electronics and Communication Engineering.
Okay. Thank you. Can you hear me?
Yes, sir.
Yes, sir. You are able to. Yeah. Good afternoon, everyone. First of all, at the very outset, I would like to congratulate the Department of ECE for conducting such a wonderful 5 days FDP on innovative approaches in IoT. Of course, with the bridging with the theory and practices As you know, there is a lot of rapid development in this area, especially in IoT. And we already established a lab, and EC department doing wonderful job in training our students. So I'm a principal of the KG Reddy College of Engineering, Sai Sachan Reddy. This college, I think, already given introduction about this college. This is a 15 years old college. It's a NAC A+, and we have NBA accredited programs and ISO certified institution, and also autonomous college. We use autonomous college. We are having 6 branches, more than 660 students are intake. Total students around 1800 plus, and 140 faculty members and 43 doctorates. This is a briefing about the college. And we are having very good center of excellences in the college, where they are doing wonderful job in terms of research and innovation, and regularly conducting the cutting edge technology workshops also. And coming to this workshop, this IoT workshop, and especially in embedded systems, which recently revolutionized in various sectors, right now, from smartphones to healthcare. And I guess in this workshop, it's a blend of, as Saida sir said, HOD. In these 5 days, I think there's a blend of lectures, live demonstrations, and I think practical sessions. Definitely, there is a good takeaway to all the participants in this 5 days program. I hope it covers IoT architecture and protocols and embedded systems for IoT, and edge computing and AI and IoT, and hands-on projects and demonstrations. I think this is a good takeaway to all the participants. And please learn and interact, make it an interactive session, and make it successful program for this 5 days, and teach and take away, and also teach to your respective students in your respective colleges. Once again, I congratulate Dr. Saida for conducting this workshop, and also supported with our Dean Academics, Dr. Nasir sir, who is supporting all these workshops and technology enhancement programs in the college. And wish you all the best, and thank you very much for inviting me to this 5 days workshop. Thank you. Wish you all the best.
Thank you.
Yes, thank you, sir. Thank you, Principal, sir. Now I request Dr. M.N. Nathayya, sir, Dean Academics and Vice Principal of KGR, sir, to address the gathering.
Thank you, Sai. Hope my voice is audible, Saida.
Yes, sir. Audible.
Yeah. Thank you, sir. Thank you for kind words. Respected principal, the one who I admire and love, Dr. Sai Satyanarayan Reddy, sir, Principal KG Reddy College of Engineering and Technology. The respected HOD, Dr. Saida, Department of ECE, and the coordinators who put a lot of efforts and brainstorm to make this particular FDP at this particular stage after a lot of brainstorm. Then the resource people, the first session resource people, Dr. Raghu, I'm able to see. Thanks for joining and to be a part of as a resource person for this particular FDP. And dear all the participants from the different organizations across the India, from different states. The theme of this particular FDP says innovative approaches in IoT and embedded system. Nowadays, like moving forward, Internet of Things, not only Internet of Things, even industrial IIoT is also, there's a lot of discussion in industry on industrial IoT. So hope this particular FDP to all the participants will really help and make you to take to the next level to understanding the industrial applications of Internet of Things. When you say Internet of Things, obviously, the lot of sensors will come into the picture. How the sensor can be integrated in the real time to sense data. Then how this data can be processed with the different algorithms, as Principal Sir mentioned. Maybe without any doubt, I can confidently say this particular FDP also will take you to the next level for the cloud computing and artificial intelligence. Because what are the data collected by the different sensors? How this data can be processed to take wise decisions. So I congratulate the Department of ECE to organize such a wonderful FDP with the title of Innovative Approaches in IoT and Embedded System, and hope this FDP really helps all the participants. And no doubt, I don't have any doubt this FDP will take you to the next level in understanding IoT, not only IoT, even industrial IoT. So once again, I wish you all the very best for the participants, and try to attend each and every session. We also informed all the resource person saying that like it's not one way of delivering as we do in the classes, because a lot of interaction should take place in this particular sessions. So I request all the participants to be active and try to, wherever you have a concerns, try to raise the concerns, and resource person that they'll try to address their concerns if any. So let's try to make use of this 5 days of time to learn something out of it. And after this FDP, let's go back to our institutions and try to reflect ourselves. What are the things we learn through this FDP? Let us try to share with our colleagues and particularly for the students, so that lot of knowledge transformation takes place by this particular FDP. So with this, once again, I congratulate the Department of ECE and the head of the department, Dr. Saida, and the coordinators and his team to organize this particular FDP. Once again, I congratulate the department, and I also wish you all the very best for the participants for the next 5 days. Once again, I wish you all the very best. Good luck, Dr. Saida.
Thank you, sir. Thank you, sir.
Thank you, Nartey, sir. Thank you, Nartey, sir.
Sai sir, take a photo for ask all the faculty and participant to on the video.
Right.
Also set the
Requesting all
background
the
photos.
participants. Yes.
Okay, na, Sai sir?
Screenshot, you take the screenshot. So rather than taking a pic, you can take the screenshot and put it in the Word so that everything will reflect same.
Yes, sir. Same thing, sir. Yeah.
Sir. Okay, right. Thank you, sir.
Sai sir, you can invite the
Yes, sir.
Raghu sir to deliver
Okay,
the.
right, sir. Right.
Yeah.
Okay, right, sir. Good evening, one and all. Now I take immense pleasure of inviting today's speaker, Dr. Raghu Indrakanti. Dr. Raghu Indrakanti has received a master's and a PhD degree in Electronics and Communication Engineering in 2018 from National Institute of Technology, Calicut. Currently, he serves as an assistant professor in the Department of Electronics and Communication Engineering at Anurag University, Hyderabad, India. He has research and teaching experience of 7+ years. He has published research papers in SCI, Scopus journals, and reputed conferences. He is a reviewer for IEEE Springer Journal. Raghu Indrakanti has research interest in reconfigurable circuits and systems for wireless communication, and artificial intelligence in medical applications, and VLSI signal processing and biomedical systems. We welcome you, Raghu, sir.
Thank you, sir. I think you have given very detailed biography, but anyway, shall I start with my session? Already we are too late, 17 minutes.
Yes,
So
sir.
Shall I
You can
start?
sir. Yes, sir.
Yes,
Okay,
sir,
right.
you can.
So I hope you can see the slides.
Yes, sir.
Right. Just give me a minute. I'll adjust things. Yes, sir. Sai, sir, please, in between, if your voice is disconnected or if any technical issue from my side, you can stop
Okay,
me and you can arise me so that I can look at what are that I can correct
sure,
myself from this side.
sure, sir,
Okay.
sure.
So just today we'll discuss. I have list of content in the session. So these topics, headings we are going to read while doing the presentation. Because it is late, because I organize around for 2 hours. I'll try to wind up the most of the content in this today's session. Anyway, on 99th, I have one more session on related to the communication. So those are the topics which I'm going to not complete today. I'll continue the next session. So first, we'll see what exactly introduction to the IoT and signal processing. So in our daily life, the usage of these IoT devices or digital devices, you talk about any sensors in our daily life, every day is increasing, because if you look at everyone using digital watches nowadays, and digital watches sensing the data and how many steps you are going to take every day, and what is your heart rate, what is the BP level, and what is the oxygen level. So there are different parameters or sensors are incorporated in the digital watches, and it's sensing the data. And this data can be readable sometimes based on your devices. And this data can be stored, and this data can be analysis for future purpose. So that is a one criteria, but these usage of these digital devices are increasing, but the data analysis part, as of we are lacking, we are not collecting the data, we are not storing the data, because it is not an easy task. Because when you're collecting this data, it is a very redundant, and most of the cases, this data analysis, again, it is a in terms of economical, because you have to incorporate a huge, very large processor to process the data and to analysis. So it is not that easy. So if you incorporate sensors in the mobile, in watches, or you can take today morning we are using. In my home, we are washing the clothes in LG washing machine. So there, because it is take almost like 1 hour 30 minutes, and I connected with my laptop, my phone. There is an app where the internet of there's a washing machine is connected to my app, and I can control here the speed and the timing of the particular washing machine. So this is one application where I can use it in a daily life. And again, there is one more IoT sensor I use in my home. That is we have like a chimney where I can fix the timing at before I go for cooking. We can buy at a room or maybe hall. I can switch on the chimney. So there is a multiple scenarios where we use IoT devices, but exactly how these devices works and what is the background, how they are connected, these devices, how the data is transforming one position to other position, connecting mobile to the device to mobile, or between any other storage spaces. So that we are going to discuss today. And along with my main, the agenda of today's session is instead of connecting discussing about the in generalized IoT devices, I was planning to give some different way of understanding the IoT or sensors, and how the sensors can be made as a research article, and how we are going to make a mathematical model instead of designing a sensors. Okay, so I'll take in that aspects. Of course, for that, I'll take an application of ECG, how the ECG signals, how we can derive the ECG signal by using mathematical formula. And I'll try to execute this mathematical formula in a MATLAB. I'll try to explain each and every step, how we have derived that formula, how this formula going to be written in a MATLAB coding, then how we can execute and see the graphical representation of particular ECG. So that is our my main agenda. So first, because today is the first day, maybe I think no one has covered what is IoT and all, but I want to take the definition of IoT from the first who is invented what is the Internet of Things, that is Kevin Aston. He said what is the Internet of Things is really about is the information technology that can gather its own information. So, and often what is does with the information is not to tell human being something, it just do something. it does something. So what exactly it means is, Internet of Things is we are collecting the data or gathering the information about the particular person or maybe particular device or particular requirement. And this data, as of now, we are collecting only the data, but we are not doing any type of processing. Okay. And it is going to convey the information about the particular need of a particular application. So that is what initially when IoT is invented by Kevin Aston. Then general definition, after that, many authors or maybe researchers, they have defined this, redefined the definition of Internet of Things. And in general, we use Internet of Things is, there is the internet, we call it as internet. Sorry. We call internet, and internet, we have many things are there. The things can be application of automotive vehicle, or maybe a fitness healthcare center. That is, we call it is mobile, healthcare body area network, or you can take a wearable electronics, or maybe it is the resource management in a particular company, or maybe a smart automation. That is a home, we can use home appliances, or maybe industrial Internet of Things. And smart lighting, where nowadays in every home, not every home, most of the high profile homes, there is everything is connected with the internet. So when you enter into the room, the light will be on, then you use your, based on the temperature and based on the intensity of a particular room, again, the light brightness will be modified, can be changed. And the smart farming and smart appliances. If you see, these are generally, we call it as the things. So it is, they are doing the things for a particular application. And this internet, what is doing is connecting all these things with the internet. Generally, they define as the internet of things. And all the things are generally, we call it as the physical devices. They are existing. These all are existing. Between this internet and the things, if you are connecting and exchanging the data, and they are communicating each other in the other way, some protocol, and that is, we call it as the Internet of Things. That is a definition. It is generally we see in any textbook. Of course, it is true. That is what generally what is meant by Internet of Things. And the devices are connected to this internet every day is increasing in the various applications. Example, if you see the latest data on how many these IoT devices are using in this current world is almost 2019, when they have done a survey, almost like 10,000 billions, so 10 billions devices are connected. They are used in 2019. And we are expecting almost like 30 billion devices are going to be used in 2025, that is which current year. It means almost like 4 times of the population of in the entire this world. It means every person has at least 4 devices, 4 IoT devices are using in our daily life. So IoT device can be anything. Maybe it is a watch, can be one IoT. In home, I have multiple devices. So in that aspect, we can see there is a 4 times of IoT devices going to be used in 2025. So this is the data I have collected from the internet. And let's see how this, IoT devices, what is the real-time scenarios, where exactly how IoT devices can be designed and we can use in real-time application. The first one is IoT assisted grocery reminder. So in our daily life, whenever we go home, whenever we go office, our wife is going, then husband will remind that, our mother will remind, okay, you bring something while coming from the office. Because in active work, most of the cases, what will happen is we'll forget everything. Maybe because in a hurry, maybe in a stress, or maybe we have the lack of work at the workplace. So while going home, we forget everything. So how we can solve this issue? So this problem running, like example, this scenario I have taken here. You're returning to home from a work after a long day, and you realize to forget check if you have enough milk at home. So I don't know how much milk, whether milk is there or not. But if I go late around 10 o'clock, then it's very difficult to get the milk that time. So how I can solve this issue? The problem is running out of milk could disrupt your next morning routine. That is like every morning, if you want to have a habit of taking a milk, but milk is not there, and you reach the home at late night, and that time you cannot get a milk. So you need to find some solution to this problem. So the solution here is connected internet refrigerator with the IoT sensors. So we are placing a IoT sensor monitors. And this IoT sensor, what is going to do is it's going to check the milk level. I mean, we have to place it a space where you have to pour the milk in a refrigerator. And based on the level, we are going to give the real time. It will give the indication that, okay, your milk is only 20% left, or 20 ml is left, or 30 ml is left, or 50 ml is left. So that information, it will get, it is connected to your mobile phone, and it will give the alarm that the milk is only this one. You have to, while returning home, you have to take a milk. So this is the one application we can make it solution. So if milk is running low, it sends a notification to your smartphone, and your IoT system synchronized with your maybe GPS. You can connect with the GPS, and whenever you're passing that car through the nearby places, it will give the notification. Oh, you can take milk, you can collect milk from this place. So that is like you can connect to your mobile, your not only smartphone, but also you can connect to your cars. And or there is a multiple option you can keep. That is, it could be even a pre-order. Like nowadays we have connected to the country what is called country mill. There you can connect that app to your refrigerator, and whenever you feel the milk is very low, then immediately automatically it will book for next day milk in the country mill. So this is like there is a solution where you can find the problem, and you can design a solution for the particular problem. And the key features for this problem is real-time inventory tracking for household essential, not only for milk, it can be anything. It can be rice, it can be some other elements, or which is maybe you can keep for medicines. Any type of problems you can keep, like because if any home, any older people are there and they require a regular medicines, but sometimes you may not check the medicine regularly. So what I want to convey here is you have to connect, you have to find the problem in your nearby places and try to figure out how this problem can be solved by using IoT, Internet of Things. So this is a one scenario, one application. The next application is IoT in your home. So where, example, just to take up an example, imagine you woke up at 7 a.m. every day to go to your work, and your alarm clock does the job of waking up just fine, because every day we are keeping the alarm at 6 o'clock, and routine every day, once alarm is rung, then we'll get up. But sometimes it may happen, you have a different scenario, like your train is cancelled, and so you have to drive to work instead, and driving take longer time. So instead of like because your train is, because you're catching the train every day, so you know the timing, the train is coming in time, like example metro. Suddenly that day, like your example, next day, tomorrow ICT conference going to be happening in VNR VJIT, and I was planning like, okay, I'll take a metro at 8 o'clock. So it take almost like 50 minutes to reach Nizampet metro station. So in that planning, I'll fix my alarm around like 7 o'clock. I'll get up at 7 o'clock, get ready till 8 o'clock, and take a vehicle till metro station. And metro station, I'll catch the metro. So it means like almost like 9 o'clock I can reach the VNR VJIT. Let's just imagine that day the metro station is cancelled. So anyway, I don't have any other option. I have to take my own vehicle or maybe the RTC bus to reach the destination. So in that scenario, generally we know that if I drive from Elbinagar to Miapur or maybe Nizampet, almost it take 2 hours of time. So the 2 hours, it means almost like instead of when my planning to reach at 9 a.m., but if I start at 8 o'clock, 8 o'clock, now if I take the driving, I'll take almost like 10 o'clock. It means I may miss the first 1 hour session. So to avoid this problem, what I can do is we have to connect a IoT device, and based on the information, like I want to travel the train, connect your train information to your IoT devices and get the information whether train is cancelled or not. Or you can connect whether it is raining outside or not. Because again, for raining weather condition also, it will take the journey time is also will varies. So these are the different scenarios where you can find the problems and try to solve these problems by using IoT devices. Like, just have a solution for this above problem. That is a connected or IoT enabled alarm clock adjustment itself based on these three factors. What is that? First one is recognize train cancellation. So if you have any information on train cancellation, connect it with your IoT devices and get the alarm that, okay, today your train is cancelled, so you have to get up early. So it will give some alarm. And second one is calculate driving distance and travel time alternative routes. So there is, because while you're traveling, generally if I take from Ilbina to Miapur, there is only one option, Miapur to Dilshuk Nagar, Dilshuk to Ilbinagar, sorry, Malakpet, Koti, and that direction. There is a one option. Second option is I can go for Uppal, then Hapsigoda, and Y Junction, Balnagar and Y Junction, and towards and JNTU. There is a two routes that generally I have, or maybe I can take sometimes the outer ring road. So based on these topics in the different directions, also I can take it. My IoT device will advise me to take a shortest path, which will take a minimal time to reach the destination. So it means we can connect your device with the latest the Google Map, or maybe the online the traffic data which is available in the internet, or I can the IMP data which is available in the internet directly. I can connect it with my device and it will give the alarming. Or maybe I can also check weather conditions and factors which is slowing the driving also, like particular direction, the raining may rain, some other direction rain may not happen. So once you get that information, it is raining the particular particular position, even if the traffic is low. So it is not a good option to drive in that road. So you have to take alternate ways. So this is the way, the second scenario where we can see the IoT devices can be implemented. And there is a third scenario wherein IoT in transportation. So this is one more example. Like, of course, this is, I think I was repeating the same example. Anyway, I'll share this data. So what exactly you need to do is you have to find the problem, what exactly it is, and whether this problem can be solved through the IoT. And when you say the call IoT, you have to see the feasibility, whether they are feasible, and they can be whether can they implement, or what is the use cases really they are essential. It is not like everywhere I can interconnect things with the internet, or that is called IoT. So it is the only way to find the problem and try to incorporate with IoT if possible, and just check it out whether it is feasible, or maybe in terms of cost effective, or maybe it is in terms of use cases. So these are all parameters you have to take care of while designing any IoT. So these are the three use cases where IoT can be incorporated, or can be designed, or can be find the solution for the particular problems. Now, why only now we have to use IoT? So because recent days, the usage of these mobile phones are increasing, the first case. And the second one is what are the chips are available in current scenario? They are very cheap. That is embedded chip. So maybe, and their size is also very small, very handy. In the earlier case, we used to see the mobile phones are very bulky, but current days we can see very lightweight mobile phones or lightweight devices. How? Because the chip sizes where we can scale to the smaller size, and we can make very low power. So it means we can increase the battery life of a particular devices, and we can incorporate both hardware and software. It means I can modify the particular IoT devices with any updated information. And the next one is communication is growing very faster. So earlier days, to communicate any person in olden days, 90s or 80s, we used to send the data through a normal letters. But nowadays we are using, if I want to talk with anybody, I can see them by using 5G communication. Just to call them, video call, and you can communicate. You can see their expression, their faces. So that is what the communication is growing in current stage. So it means the communication is growing very faster, and is also the globalization. So in terms of socioeconomics, this world is heavy globalization, and the technology is increasing not only in urban areas, In rural areas, also, the usage of IoT devices are increasing. And the competition, because there is a huge competition between the application usages in the real time. So that is the reason we have to use the IoT devices. Then is a mobility, because IoT devices is not like it is, we can fix one position. We can take to any position, anywhere, everywhere. That is what generally we see the definition of internet or Internet of Things. And there's other benefits of this IoT devices, that is automation, higher productivity. So if you increase the Internet of Things, the productivity will increase. Example, just I'll take the scenario what we have discussed. Like I forgot while bringing the milk. So what will happen? You come home. That example, you don't have any shops nearby your places. That example, milk is very essential. Tomorrow, without milk, you can't sleep. So that time, what do you have to do? You have to get the milk at any cost. So that example, again, you got information that almost like 20 kilometers you need to travel. 20 kilometers you need to travel to get the milk. So it is a essential. So you have to drive 20 kilometers. Again, coming back to home 20 kilometers. So driving 20 kilometers may take 30 minutes. Again, coming back to 30 minutes, it means you lose the 60 minutes time in your life. And at the same time, you have to use the fuel to transport one position to other position. So this is called, in terms of, if you talk about the productivity, because again, you have to, in a sleep or in a rest, you have to compromise those 60 minutes. So that will affect your physically or mentally. So that will affect your productivity. Just I can take a general example. How many these IoT devices can be more productivity if we use in industry orientation? Okay. And the second one is smart monitoring, control and maintenance. Efficiency will is very high. The cost is going to be low, and higher quality and better optimizations in terms of outcomes. And IoT devices, the early warning systems, not only in daily life, but also in healthcare. Because recent days we have seen there is a huge number of heart attacks. How this is happening? Why we are not communicating with the doctors? Is there any way to solve this issue? Yes, there is multiple ways we can solve issue. One method is called IoT. Okay, so we can send early warning, a particular person, the blood pressure, or maybe the blood cloud, or maybe the ECG. You pick up the ECG with a device which is connected to your hand, and send the data to your family doctor, and give the alarm that your health is not that good, your heart is not good. At least you can reach in time to the hospital. They can diagnose, and you can avoid this. You can say you can overcome this. Means uncertain death issue. And there's also application of dynamic responses to variable demands. So the demands are changing every day. The students, the faculty, or households, parents, or customers, their demands are increasing rapidly. They're changing. So conventional way to solve these issues is practically is not possible. So we have to find the particular other way to find the solution. And one solution generally we call it is IoT, Internet of Things. And huge and varied applications. The industry, you take agriculture, because as the agriculture is the crop is the demand of the usage of the tomatoes. When I mean, recent days, if you look at the onion and garlic, or maybe if you see the cost is not dropping from last 6-8 months. The reason those who are doing the cultivation, they are reducing the cultivation. They are not using. They're not doing. At the same time, the demand is increasing day by day. And how to solve this issue? So it means the manual, because one thing is we don't have a manual power, and the people are hesitant to do the farming. So can you try to incorporate your agriculture with IoT? Make your productivity is very larger, so that when productivity is very high, and of course the cost is going to be called down, and it is available to each and every person. That is what we call sustainable development goals. Every person should reach everything. So this is like agriculture. That is a very, very large application. There is a huge area where the large scope is there to incorporate IoT, Internet of Things, and also health. The recent trend in our daily life, the agriculture, how it is important, health is also very important. As a human being, I feel I don't have any, I never believe on a Janmas, second Janmas, another 7 Janmas. Only Janma I know, that is current generation, and we have to sustain this body which is exist in current area. So that is the way we have to incorporate, there is a scope to include IoT devices and transportation infrastructure, smart living, consumer application. There are multiple examples are there where we can incorporate IoT. It's not like simply you can take I can do in here and there. Why do we have to find the problem? And what is the requirement? And what is the solution you are going to incorporate in the particular device? So these are the basic applications and usage of the benefits of IoT in our daily life. Then before I'll give more detail about the IoT and with the signal processing, just I want to add some information which is really, it is very essential in terms of understanding Internet of Things. We don't have any other Internet of Things like other technology where we can solve all this problem? Yes, we have. One is called information technology. The other one is called operational technology. The operational technology generally we see in terms of physical world, physical devices. That is like you can take any company, hospital. These all are called operational technology. The other is called information. The information that generally information technology is called as internet data sharing. So the physical devices are and internet things are there working separately. Currently, most of the 90% application, if you pick up any 90% application, they are internet they are using, and they also have physical devices, but they are not interconnected each other. They are working as a individual. So how this Internet of Things, information technology and operational technology, they are very essential to understand what is IoT, Internet of Things. So if I look at, there is a five criteria I have taken for in respect to of OT and IT. One is called operational functions, priorities, and types of data, and security and implication of failure. So if one network is fails, what will happen? The first one is industrial operation technology network. It is keep working for 24 hours. Let example, if I take an exam in a real-time application, that is like any person, a patient who is on a ICU. So it means we have to provide a continuous oxygen 24/7 so that he can sustain his health. Otherwise, he may get a death. It means the physically should be available. If oxygen you are not providing, what will happen? Maybe you have to face the death. That is a call operational technology. And in terms of Internet of the Internet, so if Internet is gone, what will happen? Yes, the mail may not send, the data maybe may not send in WhatsApp to the other your friend, or maybe you may not share the data to the image to your friend or Instagram. So it will stop for a short duration. It is only short duration. Once that is retained, again you can send the data. So that is managing computers data and employee communication system in a secure way. That is our main operation of IT, information technology. And if you look at the priorities, operational technology, mainly the highest priority is availability. So when you take the patient, when you come the patients, first we check. During Corona, we used to check whether oxygen is available or not. So that is what our first availability. The next is integrity, whether the oxygen available, whether you have a bed. Yes, they have integrated each other. Then finally the security. Of course, this application, I never see the security, but these are the order way the priorities in the operational technology. Availability is very highest priority. The second is integrity. The third one is security. But when it comes to the information technology, the security is higher priority. So when I send any data to my friend through the email, WhatsApp, or maybe other way to communication, where I'll give the more highest priority is security. The second one is integrity. Then final is availability. So here in this availability is very least in case of information technology. But when you say the physical devices or operational technology, availability is very highest importance or priority. So how this can be incorporated each other so that I can design, it is called Internet of Things. Why Internet of Things? Because operation technology which is related to the physical devices and IT is connected to the internet. That is what definition is mentioned. Then different things are connected through the internet. Generally, we call it as Internet of Things. So let's see how we can connect this and how we can incorporate. And types of data. In operation technology, we see the monitoring, controlling, and supervisory data. Wherein in case of information technology, voice, video, transactional, and bulk data. And in terms of security in operation technologies, control devices access to the devices. Like I have an oxygen, I have to know how much oxygen have to supply to the particular patient. It is not like just, okay, I can connect the oxygen to the particular patient, then I can leave it. No, I have to control it, physical devices. But in case of internet information technology, devices and users authentications are very important. I have to check the internet. Like when I connect internet, I have to connect it, authenticate. Okay, this network is corresponding to me. I know the password, login, and internet. And if operational technology fails, what will happen? If operational internet network is disturbed, directly it is impact your business. Example, of course, you have a ICU, everything is available, but they are not able to connect it. So you may fail the business. But in case of information IT, if you lose the internet is disconnected only for short duration. You may of what are the data you're sending may be passed, but I can resend the data after some time. But once the life is gone, can I return back my life? No, it's not possible. So that is a different way we can solving these issues. That is in terms of operational technology as well as in terms of internet of information technology. And what is the responsibilities of IT and OT? So the information technology responsibilities, secure data. What are the data you're sending the data in a secure way with the organization? But in case of responsibilities of operation, oversee the physical systems like assembly lines, production facilities, and they are connected and they are depending each other. They control so that it is not going to create any abrupt changes in their responses. So historically, if we talk about IT and OT, they're working very separately. They are independent. They're working as independent. And the IoT's main intention is they bring the features of IT as well as the features of OT. Then you make as a internet of things. That is the main advantage, main intention of or the procedure to design any IoT devices. So we already discussed about the failure of OT and failure of IT. So we have to make sure that when your device is connected, like when OT fails and when IT fails, but still IoT can be replaced in these two scenarios. How we can do it? Just we'll see some examples. So we are going to integrate the physical devices, that is operational technology, and with IT system. So that we are making as a Internet of Things. And how it is possible? Yes, this is possible with adaptation of standards, that is called IP-based protocols. And we are encouraged to align with the IT and OT networks for better compatibility, because we are taking the features of both OT as IT and as well as OT. So that is a general how this IoT is derived from the information technology and operational technology. So, and of course, we can see there is one more thing about the cultural difference between IT as well as OT, because IT often schedules updates based without considering OT production. So OT, because the information technology is not depending on the physical devices. Similarly, OT relies on the specialized systems, sometimes are unfamiliar with the IT, because the devices, if I take example of ICU devices or maybe any biomedical devices, even without internet, I can perform that device. Or if I go for ultrasound image scanning, where without internet I can do it, only I require a power supply to the particular devices. Okay, so it means they have different applications. Now we are connecting these two, internet and the physical devices, which is not depending on the IT, so information technology. So this is the way we are going to design. So these differences insist to collaborative approach to manage the shared network effectively, because they have different own networks. They have to connect to each other. So how we are going to connect to each other is by using various multiple ways. That is, I can see a unified IT/OT infrastructure. It is already defined, derived, or established to support IoT initiatives. So I'm not talking about this because it is very huge topic, how this infrastructure is built incorporating IT and OT. Just I'm giving the idea how this IoT is derived from the which is existing different technology, that is Internet of Things and operational technology. That is my main intention. 1 minute. Sorry. So now just we'll deep into the topic of IoT and its application. So the devices and objects in IoT applications. The devices like where we can have implanted a body area network in a particular person, that is wearable devices, which will sense your blood pressure, heart rate, or maybe other elements. Those who are nowadays I can see just kids are wearing that sleep apnea devices, where because the kids generally they can't speak, the fetal the very almost like 8 to 9 months baby, they can't speak, so but still they have some type of sleep apnea issues where they can't sleep because of the lungs or pneumonia there in the lungs, and that will make a different sound like a grrr sound. So we are collecting that data, and by using sensors and give the information that okay, this particular baby is having a sleep apnea issue, or maybe is having a huge pneumonia in your lungs. So this is one way to diagnosis, or maybe to take a precaution to overcome the issues. Or I can take the objectives in terms of, because not only in a devices with the people, maybe I can take a IoT devices which is not connected with a human people, or I can keep a weather station, keep it outside and collect the data. What is the wind direction? What is the temperature? And whether it is going to rain. So these are the different devices or objects connected in the real-time IoT applications. So how this physical devices and internet is going to be connected to each other. So what physical devices does is, it will do sensor data, and this data can be controlled, and they're connecting all these sensors each other, because there is only not one sensor. We have multiple sensors are exist, and this sensor data be connected. And if I place a room temperature, so I can't keep a single place in room temperature. I have to place multiple positions. And of course, if I see that data which is sensing this sensor and this sensor is not much different, maybe there's a huge small different variations. So this, instead of sending this data, this multiple data at a time, so what you can do is you collect the data and take a centralized and take a decision which data need to be communicated through the internet, or to pass the data to the particular center or maybe storage places. So that is what we are going to see. That is called edge devices, or things where we are connecting the data, and these sensors going to be integrated, and the data can be, before you send, you need to process the data, and with the low power systems, because and only we are sending only little data, not every data, because in temperature, if you take in temperature, maybe in a particular room, almost like 27 degrees. If I take maybe here 27 degree, if it is the fan is nearby, and if you have a here, there is no fan, maybe it is a 27.6, some just only 0.6 variation is there. That is not going to impact entire this space. So it means it is a redundant data to share all this, like which is having the same information. So we have to send only a little data to the cloud, or data to store in a cloud to take a decision. And this data, when you're sending the data, it is not only one data. Maybe you can clipping multiple areas, and all this data be connected and interconnected. And finally, we are storing in a cloud. So this is how the physical devices are connected to the digital worlds. Now we'll see what is the different components which exist in the IoT systems. The first one, these are the main topics, main devices, components, which are almost exist in each and every IoT systems. First one is sensors, actuators. The sensor, which is collect the information from the environmental, temperature, humidity, or maybe if it's a body, then you take an ECG or blood pressure, or maybe the hand movement, that is the number of steps you have taken for the particular day, or maybe the actuators, which performs actions based on your decision. So like you take a switch on a light, and you can take a switch off a light, and you are taking recently, I have with my students, we have developed a AI-based podium, where you have to, once the speaker comes and stand, based on this height position, the height of this podium is increasing and decreasing instead of adjusting the mic continuously. So it means this actuator does it changing its action, take a decision based on the particular application. And the next one is communication protocols. So again, how the sensors are communicating the shorter distance, or maybe it is a longer distance, or maybe you need a high-speed data communication or application where the data is you have to do very fast, you have to send the data. So if it is short-range communication, we go for Bluetooth and ZigBee. And this Bluetooth and ZigBee, I'll try to incorporate this related to this information in the on 9th January in my next session. And long-range communication, how this LoRa, that is a LoRa is the LoRa long-range communication, long-range WAN or NB-IoT devices. And for high speed, we go for 5G communication currently, what we are using. Sorry. And the next one is data storage. So we have sensor data. We are communicating through a particular protocol, maybe communication or a channel. Then finally, we have to store this data for the future purpose, because we have to, every device has to train and take a decision based on the data. Without data, you can't do anything. So that is data and processing. Whatever processing, so what are the data we are receiving, then we have to find the redundant data, or what is the data we are sending through the internet. So this, when you're sending the data through the internet, and this data can be, the noise can be incorporated in your received data, you have to filter the data, or maybe some data is redundant that you have to remove it. So the data processing, data storage and data processing are one more components in the IoT device. The final one is user interference. Like we are, the watch is connecting the blood, your heartbeat or blood pressure, but without display, how you are going to know that how many, whether you are, what is your heartbeat, what is the blood pressure? So it means you require user interference. That is maybe an app, maybe a web dashboard, or maybe voice assistant. It can tell you, okay, do this one, or maybe you can see the web dashboard where it can display all these values. Or maybe mobile application, open the app, then within app, you can open, again, see what is the blood pressure and humidity or particular area. Okay, so these are the main component, which is very essential and exist in each and every applications of IoT devices. Most of the applications, or some application or IoT systems, maybe there are other components, but these are very essential to design any IoT system. So I have some applications, some architectures, how these IoT systems are connected. So that is, we call it as edge, that is the input and output devices. In the cloud, where the centralized data is going to be processed, we call it as a hub. And there is a first application is a smart appliances. So smart appliances, we have edge devices. And there is a call as a hub where we are connecting. There is a user interference. So in hub, edge devices, smart appliances, we can send data edge to hub and hub to edge. And once the data is reached up, then we can see in a graphical user interference. And the graphical user interference again send the information, or you can select the data. You can send information to the edge devices through the hub. Just I can take an example of, I was telling right morning, we have a fridge, washing machine, and I want to control how much time this washing machine need to be run. Maybe it is a 45 minutes, or maybe 1 hour 30 minutes based on the quantity, number of cloth I'm going to keep it inside, or maybe the different type of cloths. So what I do is, because I was rushing to the office, maybe I started the washing machine at 7 o'clock, but I have to be there to remove or dry, almost like if I choose 1 hour 30 minutes or 1 hour 30 minutes. So 1 hour 30 minutes. But I have to reach the office by 9 o'clock. It means at least I need to start by 8 a.m. So it means I have left out only 1 hour. But this remaining 30 minutes, I need to control this device. How we can control device? This is called edge devices. And what it does is, it will send the data to through the hub. And hub, I can see by using user interference, maybe in an app. I will open the app. There I can see the timing. There I can fix. I can choose based on my requirement. I can choose this one or this one or this one. Once the job is done, I can so once I receive the information, okay, 30% is over. Next I want to, I'll get the data from the graphical user interference. There, again, select what is my next action need to be performed in a edge device. How? I send the data through the internet, and internet is connected to the hub is connected to the edge devices. So this is the way we can design any architecture of a IoT devices particular application. So this is the case of smart application. The next is we can see the monitoring system. So monitoring system is also one application where we can see the multiple blocks are included. So this is I'm giving the overall overview of structure of how the IoT devices and that is we call it is internet, IT, and OT is connected. I'm coming together. I'm making bridge between OT and IT. So that is why we call IoT. Okay. So how this monitoring system is? We need a sensor, which is monitor sensor, collect the data, and there is an internet we need to connect, and the database data is going to be stored. There's the dashboard. Again, we have to display the data. Let example, we take a weather station. Weather station, what is this? It is collecting the data in terms of temperature, or maybe rain, if it is going to rain, or maybe what is the next temperature for tomorrow. So there is a device, and devices having a sensor which collect the data and send the data to the hub. We are storing in a database because we have to collect the previous data, and previous data we need, based on the previous data, we need to do analysis. Okay, last year, this data, this temperature and this humidity, it is rain. So this year, this temperature, this humidity is happen. So that you can do analysis and take a decision. They can say that it is going to rain. That is what we are going to see every day. So today morning when I start, it will show first one, this area, it will take 30 minutes to travel your distance. And based on the data, what are the data is collected? Currently, what is the current data? And based on this data, it will display, okay, you have the 30 minutes taken. So in this application, we are not sending any information back to the edge devices. So let's see. The previous example, we have seen the data from the user interference dashboard to the edge devices. But in this application, we don't have any sending any information. It is only forward data. Because example, weather station, just to collect the data. Weather station never accept any data because always only select the data and send it to the hub and database analysis. Then we are performing just looking at the dashboard. And based on this data, I'll do my other action will depends. So whether if it is raining, then before I leave from office or home, I'll try to take one umbrella. Or if it is raining, okay, I don't have an umbrella, then instead of taking bike, I'll take a car. So this is like how this IoT is going to be structured. So this is the second monitoring system IoT architectures. And this is the third one, that is control system. The control system, again, I can control, but example, just I'm taking a practical example. That is like a fan. We have a fan. So we have sensors based on the temperature in particular room. Then we have to increase the fan speed. If it is a high temperature, increase the fan speed. Low temperature, decrease the fan. So again, we are collecting the sensor and we are storing in a database. And the database will tell me what is what we need to take a decision. Whether temperature is very high or temperature is low, very low. And then finally, once you get this information, then by using actuator, what it does? It will control its temperature. Like I have generally we call it as a regulator, and the regulator I can choose a particular position, or maybe it is a speed is 2, 3, 4, or 5. So I can control this one. So this is the way we can do a control system, which is incorporating a IoT system architectures. And so with respect to this, we have different things are there. That is one we call it as sensors. And then for finally doing computation, then we are doing controlling, and we are storing, and we are communicating. So these are the essential blocks in any internet of things: sense, computation, control, storage, and communication. Sai sir.
Sir, tell me, sir.
Yeah. So because I was moving only, it is one directional communication. So if anyone is having questions, you can stop me. So they can ask question, right? You have muted everybody, or you can open.
No, sir, we have unmuted everyone. Everyone can ask the question.
Okay,
not
or
a
else
problem.
you can drop a message, or you can drop a question in the chat box, and sir, you can read that question, then I'll try to answer this question.
Okay, sir. Okay, sir. Right.
So before you see
Respected
the,
sir, okay, sir, you continue with the presentation.
the voice is clear, sir, from my side?
Yes, sir. Yes, sir. Yes, sir. Your voice is clear.
Yeah, right. Thank you. So before we see the what is the layer of architecture, layers in the IoT, just I want to make it just because just we are revising this topic because we have studied in our engineering as well as we have maybe some student faculty already taught this subject. So they have discussed about what is OSI model. So I want to skip this part. But anyway, just I want to highlight few things which is very important to understand Internet of Things, that is IoT. That is one is called physical, that is mechanical and electrical. So all physical devices which falls in this category. That is, next is these devices, when you have a one sensor and other sensor, I need to make a link. Okay, so it means I need to be connected end-to-end. That is, we call it is networking, end-to-end services, or maybe internet to OT, that is operational data, physical devices or physical device to internet. So this end to the networking will take care of this process. This layer will take care of this one. And transportation, that is the connection between one sensor node to other sensor node. It is not like most of the application, we have multiple sensors exist and all the sensors will be connected each other. So then mean there should be connected. And then we call session. The session is related to the application dialog control, where I can, because this is a usage is very less. Next is application. So user application, what is the user application? So in particular application is the control system, or it is a monitoring system, or maybe smart appliances, or maybe it is a automotive field or industrial. So based on your application, this layer architecture will be changes. And very important one is called data link. So it means you're sending the data from IoT devices to your storage places. So because everything you're sending in a cloud or free space, so someone should not attack on your data. Let example, you have a ECG, you're taking a doctor, you're connected to the doctor, and you're connecting the ECG a particular person, and this data you're sending to your doctor. And in between doctor and some your enemy, if it is attacked on your data, and you got a severe heart attack, and ECG is already clearly mentioned, your ECG is very abnormal, and before it is reaches, maybe he can modify that data. So if it is data is modified, and he modified such a way that your heartbeat is or ECG is very clear. So the doctors give suggestion that no, don't worry, it's maybe just it is normal pain. It's not maybe due to the acidity. It's not due to the heart attack or maybe the other heart disease. So in that scenario, of course, you are going to face the difficulties because really your heart is in a big trouble, but still someone has attack on your data. So it means how reliable data is going to be transported to the one position to other position, or network to, or one device to other devices. So that is very important. So physical devices, physical data link, networking, transportation, and application. So these are the main layers which is very really usable in the IoT devices. Of course, they have a representation is also very important, and session is also exists, but compared to these layers, these are the very important. And again, the same thing I was discussing just now. So there are different layer approaches in the IoT. One is the perception layer, which is focusing on the physical sensors and accumulators. Generally, we call it as a physical layer. And then network layer. The network layer, which is connecting the one device to other devices, or storage classes or processing elements. And processing layer, which analyze the process of the collected data. And the final one is application layer. So application layer where why you need to design or incorporate IoT in particular application? Is the realities of it is essential, or really it is useful for you, or only for some sake of IoT or technology you have, or you are into using them? So it is again the way application layer is going to decide. So it provides service to the end user. So if end user is not satisfied, then there is no deployment of IoT is not required. And next one is now we are just I'll enter into the main how the signal processing techniques are they are using in IoT. So here, if I look at some application like when you design any IoT, any model, so generally what we have is data. This data can be continuous, or maybe it is a discrete. Generally, what are the data we collect in real time, and all this data is generally they are in a continuous in nature. But I can't do a process this data in continuous domain. The reason here is if I take any continuous time signal or continuous data, so if I take any fraction of time, maybe like take a 1 second time. So that is like between this time to this time, there is a 1 second. And this time, because the data is continuous, and this continuous data having, if I take this region, this region, I may have, this is like 1.0000000000001 second. So that is one time I can obtain one particular value. At the same time, 1.0000125. There is a one more value. And I'll take 1.00000126778. I'll get. So what it means is a continuous time signal, generally it having a infinite number of amount of sample values, or I can say it is a data. And whatever you're taking the devices or digital devices, it is a mobile phone, or maybe you can take in a smartwatch. So they are working on very low power. It means the power or the battery supply, which is having the very low. So generally you use mobile phone, I'll take 5 volts per watt or 5000 milliwatts of watt. So how long it works? It will work for almost like some 12 to 15 hours, around 15 hours. But if I do processing of this infinite data, what will happen? When I do this processing means at least if you send this data to the base station or maybe storage a hub or centralized server, meanwhile sending the data, your battery is going to be drained out very fast. It means fraction of seconds, you may lose entire battery. Again, you have to charge it, or maybe you have to continuously power supply to your devices, which is practically it is not possible. We are not going to connect your devices continuously battery. So it means instead of this data going to be processed in a continuous domain, generally we do the digital domain. What is the digital domain is? We do the sampling theorem. And then after the sampling, we do the digitalization. So what is sampling theorem is? If I take a signal is x of t, okay, and x of t is equal to, if I take this continuous time signal, the signal is continuous in nature. And what is continuity? This t, we are replacing t equal to small n into ts, where ts is called as sampling time. The sampling time equal to 1 by sampling frequency. And the sampling frequency is related to the formula is fs equal to 2 into fm. So this is called, fm is called as maximum frequency component, which is present in the given signal. Because this signal is not a sinusoidal signal, which is having only one frequency, because this signal is having the random signal. All random signals have multiple frequencies. They have multiple frequencies, or I can say that they are sum of various sinusoidal signal with a different central frequency or frequency component, or simply I can say frequency component. So in this signal, we have to find out which is the maximum frequency component, and that maximum frequency component will decide your sampling frequency. And the sampling frequency define your sampling time, and sampling point defines how to convert a continuous time signal to discrete time or digital or discrete time signal. So in discrete time signal, what we do is we replace x of t with x of n into ts. So where ts is, so what we do is we divide this entire signal only in distinct interval of time. So this is called example 1. This is 2. The distance between this sample and this sample is called as sampling time, ts. And how we are ts? Ts we are getting from the 2 into fm. That is maximum frequency component. So like this, I'm going to get all the digital data. And this process is called discrete time signal. And this discrete time signal, if I further do quantization, in communication, you have learned the quantization. So when you do quantization, I'll get digital signals. And only this digital data we are going to store in a memory or maybe in a storage spaces instead of storing the continuous data. And here, if you see here, this is n is equal to sampling index. Generally, we call it as a sample index. And finally, we are obtaining a discrete time signals. And the discrete time signals, if you look at here, the signals are only defined at distinct interval of time. That is n equal to 1, n equal to 2, n equal to 3, 4, 5, 6, 7, 8. And what about these values? Yes, these values are undefined. The values are not defined. They're not even zeros. They are undefined. So instead of continuous, we are getting only a discrete time signal. The discrete time signal is, if I look at the shape of the signal, is same, but only the values are defined at distinct interval of time. So it means data acquisition are very, very broad topic in a IoT devices. Where is the large scope? How this data going to be acquisition and how we are going to process this data. So that is what I was planning about my lectures. My today's session is depending on this. And I can take one more example, that is a noise reduction. So once you collect this data, because already we know what are the data we are transmitting, that is transmitting in wireless free space. When it's a free space, every time there is one noise is all will be added. The noise is called as AWGN, additive white Gaussian noise. This noise can't be removable. You can't be avoidable this noise. So it means minimum you have to filter this particular noise. Or every device is also make, or internal component of any devices is also may also create a noise in the data. So if example your data is very low data, and or maybe amplitude is very low, but still noise is very high. So you can't, I mean, you can't figure out, we can't get a proper information. So before you process the data and take a decision, what you need to do is you have to remove the noise. How we can remove the noise? There are multiple applications are there. So either I can go for general application, you go for filtering. Again, filtering, you can talk about a analog filter or maybe digital filter. Because we are in digital, after data, what are the data we have is digitization data, that is x of n equal to a discrete sample values. And discrete sample values, we have to go for digital filters. And what are the digital filters that exist? Of course, we have only two techniques are there. One is called FIR, that is called IIR. FIR is called finite impulse response filter, and IIR is called as infinite impulse response filter. So I'll give the more detail about this IIR and FIR filter in the next on 9th, while discussing a communication with IoT devices application. Then next is we can take a signal processing part, where that is called feature extraction. So once you get the data, temperature, or maybe some example, or maybe it is a heart rate, or maybe you can take a blood pressure. There you can apply a different techniques. It's called Fourier transformation or wavelet transformation. So Fourier transform we can use for only for when we are converting into time domain to frequency domain, and wavelet transform when we have signal to analyze both time as well as frequency. So if you require time as well as the frequency resolution, we can go for wavelet transformation. Again, wavelet, we have different techniques are there. Maybe DWT, discrete wavelet transform, or maybe wavelet packets, or lifting scheme, or maybe Gabor wavelet. So there are a number of techniques are there, signal processing techniques, where we can extract the data which is received from, we are extracting from the sensors, or sensor data can be extract from sensor data, we can extract a different features for the taking a proper decision. Then finally, sometimes we have to apply compression also. This is also one more area where we have to concentrate in a IoT application, that is a compression. So when you have multiple sensors, so it means this data is having almost similar features, and this data also having similar features. So it means we have to do compression, because instead of storing this same data in a same memory location, so what we can do is we can compress it, remove a unwanted data or maybe redundant data. So that is called compression. So I can give the compression of a practical application or maybe usage. In our daily life, we use it. So while you're capturing an image, of course, that is also sensor. We call it as a sensor, camera sensor. And the sensor will capture the image. Yes, sir. Any question? Okay. So this image well is 64 megapixel camera. Approximately, it will create, maybe you're going to create an image. The image size is going to be 4 megapixel to some 8 megapixel image size. And the same image, if I pass through a WhatsApp to your friend, and if you look at that image size, that is in terms of KB. How it is possible? Because this WhatsApp storage devices, what it does is, before you share these original images, it do the compression. So it means it remove the or redundant information from the given information, which is still not going to affect your original features. So this is called compression. So in when we are collecting the data from the IoT devices, we have to apply a various signal processing techniques. Either can be data acquisition or sampling digitization, or maybe you can go for noise reduction, or maybe feature extraction and compression. So that is where the signal processing is falls in the IoT devices or IoT system. So again, signal processing having the huge applications in IoT. Either it can be a healthcare, or maybe smart cities, or industrial IoT. So that is IIoT. These are the different ways where we can see the scope or research area where our current work is going on in this domain. Today, I'm going to concentrate one thing that is called ECG. Okay, so that is real-time ECG and EEG analysis of remote monitoring system. So the patient is sitting at home, doctor is in hospital, still without going to the hospital or maybe traveling to the hospital, I can send my ECG data and the doctor can tell me a precaution, what we need to take before I reach to the hospital. So that is one application. And smart cities, noise pollution, traffic monitoring, where I can tell you like every year we see the Delhi, they have pollution level is very bad and the people, most of the offices are going to be off. Even Supreme Court is also will be halt for a few days. They are not, they run from the work from home. So these are the real-time application, real-time problems we are facing in our daily life. So where we can include a IoT devices and which is depending on the signal processing, because you have to collect the data, you have to monitoring, you have to process the data. Next is industrial IoT, that is vibration analysis predictive for maintenance. So when you design any machine and we need to in every regular time interval, we have to analyze the vibration of a particular devices. So as vibration is increases, what will happen? Your device is going to be forming, the performance is going to be low, and this production is going to be affected. So every day you have to, we have to find the vibration of a particular particular machinery and then process the data, and then you take a decision whether you have to go for any repair or maybe you have to do some service, general service for the particular devices. So these are the various applications where we can incorporate signal processing in the IoT and where we can do the project research works also to publish, to get a good papers. And already I mentioned, I was concentrating on biomedical or signal processing. So when you say it is, I can't say it is a of course biomedical, but it's a part of signal processing. So I will talk about what is the ECG. ECG generally we call it as a electrocardiography. So what is this? The ECG does is the process of recording the electricity activity of a heart over the period of time using electrodes placed on a chest body. So already I think whenever you are not feeling well, so even last year I was eating very continuously acidity food, masala food, and I was almost like 15 days I was getting chest pain. So in between, one of my friend brother has passed away sudden death due to the corona during corona time. So my wife is she's scolding me like, I think you are getting chest pain, you're telling chest pain and you're ignoring why you can't go to hospital and check your ECG. I went to doctor hospital, I told doctor has starting asking question, what you're eating from last 10 days, what is your activity, whether you can run, you can walk, you can run, you can take steps. So then he said, actually it is not required, you can go home without any doubt. Still I hesitate to take a ECG. After taking ECG, it was very normal. Then he said, due to the stress, due to your maybe acidity or muscle strain, you can also get a chest pain. So all chest pain is not a heart disease issues. So okay, that is the one generally I have experience in my day in my life. So how the ECGs works? So I'm not going to take any devices or sensor ECG, but my intention is how I can design or derive a ECG signal with a mathematical model. That is what I'm going to explain today. But before jumping into the topic, just I'll explain what is the ECG and what are the basic parameters, which is ECG. Based on those parameters, we can tell whether heart is having a disease or maybe it is having heart is working functionally properly. So that is generally we call it is PQ, RST, RST. So these are the main parameters where we can understand about the particular ECG. ECG generally is when you see the heart rate, we say 1 second. Okay, so 1 minute, how many times the heart is beating? Generally, we take over 72 beats. So we can generally ECG signal we take care of. Generally, we go for 10 seconds when you take ECG in a real time. Minimum 10 seconds they take. And they use generally practically most of the cases we use 12 lead ECG. That is practically we use in our daily life or most of the hospitals. Very complicated cases, we can go for 15 as well as 18. There are different types of ECG models. And in this case, we can see there is a call as PR interval and a P wave. So this wave, QRS wave, and we call it is QRS1, and other we call it is T wave. So these are very, very important to understand or to analyze ECG of a or heart issue of a particular person. So the variation in this one and the variation in this amplitude, of course, the time and the variation in this one, we can tell you, we can take a prediction, or maybe it is only a alarm regarding your heart issue. So there is we call this a wave. A wave is called either is positive or it can be negative. So if you see this one is positive, and here you can see negative. Negative deflection from the baseline indicating a specific electrical event. So generally we have different waves are there. One is called P wave. This one is called P wave. And this is called Q wave. And this is called R wave. This main region is called R wave. And then we call as a S wave. So if you see here, P is positive, Q is negative, S is negative, and R is positive. And there is another wave is called as U wave as well as T wave. And T wave, U waves are positive. They are positive. And then you can see there is one more parameter is called interval. So that is PR interval. So this time to, before you start Q, that is we call it is PR interval. And there is one more point, it is called as the J. J to end of T is called as S interval, ST interval. And from P to Q is called as a segment. That is segment is called PR segment. The PR segment neither positive, neither negative. It means always it is either zero only. And there is called as a QRS duration. So this is a duration. Based on this duration, you can see what is the heart rate issue. That is a main parameter. And we have one more thing is that is called QT interval. The QT interval is from Q to your T. So that is we have seen this is a T starting this point, that is QRT. And then RR interval. What is RR interval is the peak, this one. Let example, this is 0th second. And this is called first 1 second. So 0 to 1. Or maybe if it is happening at 1 second, this is going to be happen at 2 seconds. So the distance between this rate to this point also is called as R interval. So these are the different interval where the doctor will, based on these values, position and the width, he can just give a suggestion whether your heart is working, functioning or properly or not. And there's a segmentation, of course, I have already talked about this. And there's a one point is called this, the point that is called this J. J point is marks the end of a QRS complex. So this is will define J junction. This point is defines your QRS complex, end of your QRS complex. So when this ECG is started, is first ECG is derived by the Endoven, and he is built first clinical EKG. Generally, we call it in initial stage, it is called as EKG. K also stands for cardiogram. Okay, but after that, they reframe it as a ECG in 1903. And with respect to his works only, he only the first person who is derived this concept is called as PQRST deflections. And based on his work, he received a Nobel Prize in 1924. And again, there is a different authors. They have a modified, and finally, we are using a 12-lead electrocardiogram. Just I'll show what is meant by 12-lead electrocardiogram, and when we have to use 12-lead and when we have to use a 15 and 18. So based on your requirement or cases or different cases scenarios, the doctor will go for 12, 15 or 18. So, but standard ECG color data is called as 12. So most commonly used this 12-lead is for conduction abnormalities. So if there is an abnormal in your heart rate and enlarged heart chambers, when your heart is pumping very bigger, and low and high calcium and potassium levels, when your body is having calcium high level, potassium level is very low and high, that the case, and effects of some medications. Sometimes when you take medications, it will affect your heart also. So that time you feel stress, and the stress will leads to your chest pain. So then you feel that it is a heart issue, but no, actually it is maybe some other reasons. So these are the in these cases, generally we go for standard 12-lead ECG. Then we have 15-lead ECG, that is 3 chest leads are added across the right parallelogram. So again, we are extra 3, we are going to add in the along with the 12. So that is a 3. And generally we use this valuable tool for early diagnosis of right ventricular. So generally chest pain, sometimes what will happen is below your chest or left side abdomen, or sometimes what will happen is your nerve system from left ear to your shoulder. So sometimes you get a pain. So that case we'll go for 15-lead. And similarly for 18 is also same cases for different diagnosis. Because I'm not medically, I don't have that information. So I can't, sorry, I don't have clear data about why we have to use the 8-lead and all. So in conventionally we use for 12-lead ECG signals. So this is a way we can get a ECG signal. And I don't have a figure. Where is the figure ECG? Oh, sorry. I don't have a figure of ECG, fine, anyway. Just I can see this example. So there are different leads are there, and we are connecting in the different portion of your body, and that ECG is going to be collected. So now, as a research scholar, as a faculty academician, we don't have these facilities in our campus, academics, our campus, colleges. So how I can do the research work in this domain? So that is very, very important. Okay. So for that, what I can do is I derived a formula. Sorry. So by using Fourier transformation, Fourier series, I can do this analysis. Okay. So, Sai sir?
Yes, sir. Tell me.
Yeah. Okay. So ECG now, we have to draw the ECG. How ECG is there? First we have a, sorry. So ECGs we have called, first one is we have a P waves, then QRST and T, then U, then again P, Q, R, S, and T. Again, U follows. Then this is the procedure we have. Generally, we get a ECG signals. So now, so by using, because if you have a leads, then you connect particular person. And once if you use that leads, I can't reuse those leads. I have to go for new leads. So it is very cost effective to make any ECG devices in the research application, because only one ECG is not sufficient to analyze your model or your structure for the particular research work. So it means you have to create a variations of different types of ECGs. Of course, in online, there are multiple ECGs that are applied. data is available. But still, if you want to create your own, and your research paper article should be more mathematical to understand, okay, you have done a ground level or base level, and surely I can give guarantee that the paper is going to be accepted. So for that, you have to understand how the signal is going to be generated. So it is very simple concepts. What I'm going to do is, based on these features, if it is because I need to plot, one is called P, and the other one is we have called QRST. So that is called Q, or maybe I can say this simply, I can say the R. And again, I have some U and T and S and Q. So these are the main signals I need to plot. So what I do is, this entire ECG, we can divide into different segments. So what I do is I'll suppress everything. So what you can see here is, if you take this one, this is going to be one signal, and second signal is this one. Okay. So if you see here, this one and this one, this one and this one, what you can observe here is, it is called this. If I take this duration to this duration, it is called as, generally it is look like a same. This pattern and this pattern is same. What it means? The signals are repeating. What is the repeating? Repeating mean we can make the signal in a mathematical model, and the signals are called as periodic signal. So what is periodic signal? A x of t equal to x of t plus capital T. X of t plus capital T. Mean ECG signal, if I do time shift with the capital T, T is for smallest positive integer. And if I get the same thing, I call it as a periodic nature. So by using this periodic nature, because most of the ECG signals are periodic in a given time, so 22 or maybe 1 minute or 2 minutes time, the ECG, most of the cases never varies. Almost they look like a periodic. It's repeating the same cycle. So based on this context, we can design this ECG signal by using the concept is called as Fourier series. Fourier series. What this Fourier series does is, what this Fourier series conveys is, we can decompose any signal x of t in terms of weighted sum of sinusoidal signals. Weighted sum of sinusoidal. So let example, f is a one signal, and the signal can be decomposed into weighted sum as this an, and this bn is called as coefficients or weights with sinusoidal, either cos or sine. Okay, it means any periodic signal, a signal which is periodic in nature, can be decomposed into a sum of weighted sinusoidal. So it means we can design any periodic signal by using sum of sinusoidal signal. This is the one case you can see, it is look like a rectangle signal. But the signal can be designed by using sum of sinusoidal. If I take only one sinusoidal signal, it is look like this. One sinusoidal signal. And if I take two sinusoidal signals, sum of two sinusoidal signal, it may look like this. And if I include few more sinusoidal signals, it may look like this. And if we include hundreds of sinusoidal signals, sum of hundreds of sinusoidal signals, finally I'll get a approximation of square wave. It means any periodic signal can be decomposed into sum of weighted sinusoidals. So based on this concept, we can design a ECG signal from a Fourier series concept. How we can series Fourier series concept? Of course, Fourier series means we need to satisfy Dirichlet conditions. What are the Dirichlet conditions? The signal should be absolutely integrable. So if I take a ECG signal, whether we need to check whether the signal is absolutely integrable. Yes. And the signal should have minimum maxima. Yes. I have minimum maxima. This is the minimum value. And this is minimum value. This is maximum value. Or in between I have other values also. So this condition also satisfied. And it has finite number of discontinuities. Yes. It is started from here. It is stopped here. Again, it is repeating same thing. So we have finite number of discontinuities. So it means this ECG signal, ECG or EEG signal are satisfying all these Fourier series Dirichlet condition properties. So it means we can apply a Fourier series to derive a ECG signal. So that is what I'm going to do today. This is, we can see, I'm going to design, I'll derive for only first QRS portion. Then we can repeat the same for other cases also. So I have taken only QRS pulse and the remaining I made it as a 0. So if you look at in this previous graph, so we have picked up only this graph and this graph. The remaining all we assume it is a 0. So that is the first case. So this is ECG signal and ECG of QPRS codes. And if you look at here, this is 0 and this is somewhere else and this is somewhere else. Okay. So if you look at here, and of course, this is some values. Maybe I can take any different limits value. Maybe it is 0 to 0.2, 0.3, or maybe you can take any variable. And if you see this graph and this graph, is it both are same? Yes, both are same only. So this time, if we shift to this portion, I'll get from here to here. It means this is called periodic in nature. So this signal can be represented because it is a ramp, negative ramp. This is a positive ramp. And we can plot this mathematical representation, this one. So I can, if you mathematically define, I'll get this formula. Then from using this formula, how we are going to derive because the f of x is a periodic signal, and this periodic signal can be converted into ECG signal. So ECG signal we can convert into Fourier series formula. We need to find the Fourier series coefficients. One is called A0. Next one is AN, then BN. So here, AN, BN, A0 is called as Fourier series coefficients. And how we can obtain A0 is 1 by L, that is the length of a signal, and limits minus L to L, that is minus pi to plus pi. And of course, because this is only, we are taking only this cycle, that is positive time to negative time. So I can take this example. This is positive time to negative time. Sorry. Positive time to negative time. And then that is, if you do integration over this time, I'll get A0 value. And Bn value, what we are doing is, to obtain this An value, we have to transform this f of x with respect to this sinusoidal component, that is cos theta. So if you find the overlap area under this cos theta under this signal f of x, then we'll get An and similarly Bn. So now we have a formula, first one An equal to f of x over the time, this time, and over the time t, and into cos theta. So if you simplify this expression, you'll get the answer is called 2b by n square pi square 1 minus cos pi into n into pi by b. How we are obtaining this expression is, we have to replace f of x by this terminology between 0 to L by b and minus L by b to x. So if you represent this value, simplify this integration, I'll get this answer. But for your reference, I have derived this formula. Anyway, I'll share this PPT of this PDF. You can go through it also after this session. So first An, what is the formula? This is the formula we have. And F, so we already know what is An equal to, because it is a value, that is minus L to pi L. So if I take this negative time or positive time, both are same only, and both are having the equal distance. So I need to do only 0 to, this time only I need to perform integration. I no need to perform the integration of this time. So it means this is the equivalent to this one. So I can only do for 2 times, that is 0 to L, and 2 times it is, and f of x into cos of 2 pi, and substitute f value in this expression. So if you look at here, a is a constant when you multiply. So a into cos of n into pi by L, and the next one is minus ba into x by L into cos x. So there is a x into cos x and integration, that is the UV formula we have. So it means we have to simplify this expression, and that is we take this I, the I is corresponding to 0 to L by 2, x into cos term, and next one is I2, that is a into cos term. So this is a very simple way we can do it, but there we have to little bit complicated to solve this equation. So we're solving I1, that is I1 equal to, if I substitute this formula, so because minus b by L is constant, so you take it this integrations, and x into cos of n into pi into x. So that is we have called it as U and V. So that is X is called U and V is we take this term is dV. And if you simplify finally this expression, because I'm not going in detail about this expression, simplify all this integration differentiation, then finally you'll end up with this expression is called I1. So this is my I1 value. Similarly, I2 value is equal to A is a constant, take it out. And if I do cos integration, you'll get sine, and limits are 0 to L by 2. Substitute your limits, then finally you'll get L equal to L into N into pi by cos of how we can get this expression. So anyway, I'll solve this one. So that is cos sine of N into pi x divided by L divided by d by dx into N into pi x divided by L. So here N into pi by L is constant, you take it outside, and then we will get here is A divided by N into pi divided by L, and d by dx is 1. So it means the L is going to numerator, and that is A into L divided by N into pi, and sine will become sine only, sine into N into pi. X value is equal to, we are substituting X. What is X value? X value is 0. Sine 0 is 0, and sine L X is equal to L pi by 2. So you substitute here, that is sine of N into pi L by 2 divided by L. So here is 2 will denominator, and this N L is going to cancel out, and you will X okay, L will cancel out. It is B. So you will get sine of N into pi by B. So finally you will get I2 value. And if I do sum of this I1 and I2 value, I'll end up with one expression. That expression is called as, finally you'll simplify, that is AN value. So this is AN is Fourier series coefficient. Similarly for BN straightforward, I can get the value is 0. The reason is f of is a real value, and real it is a symmetry. What is sinusoidal signal? Sinusoidal signal generally is symmetry. So sinusoidal signal generally is happen with 0 to pi. But the f is, we have, if you look at this expression, this is called even signal because it is a symmetry. So if I look at this direction or this direction, the graph, the representation of QRS is look like same. So it is symmetry. For symmetry into, because symmetry, that is odd into even function, always will get value is 0 because of it is even function. So finally we'll get Bx value 0. Then finally we got f of x equal to this expression. So just I'll open the code, how this program is executed. So before that we can generate, we can continue the same part because time is running. Anyway, I'll explain this graphical once again, how PQRST also we can derive. I'll show how this mathematical model is derived. So now we don't have any leads to find the ECG, but still we can generate ECG signal by using mathematical formula. So in your research paper, you can include this type of equations. Not only I'm talking about ECG, you can pick up any problem and try to derive the formulas and execute it. Then you can, when you incorporate this type of mathematical analysis in your research paper, I can guarantee that your paper without any much major review, the paper going to be accepted. But simply if you without any mathematical formula, just if you keep this is application, this is the devices, this is a connected, this is a block diagram, people may not be understandable or may not be easy to analyze your paper. So here this is a code I have developed here. So this is called PQRST waves. Anyway, I'll show this formula. So we have generated QRS, right? Sorry. QRS, no, this one. QRS, yeah. So you can see here, the harmonic is 2 into B into A divided by I square into B into Y. That is 1 minus cos of this expression. Of course, I have, this is, anyway, I'll give much details. So by using this formula, you can go back and see what is the formula is for Q. So this is the formula. Okay. So that is 2 into BA divided by N square into pi square, 1 minus cos of N into pi by B. So there is a B value, N value, pi value, and this value. So that is what we have represented. B into 2 into B into A divided by I square. I ante N square and pi square. Okay. And into 1 minus cos of this I mean we already mentioned N pi divided by B into cos of this function, that is cos term. This is a H value, this is a cos function. So finally you're getting this expression. So this is a cos and this AN is this term. And finally, just I'm plotting the graph. So here we are not only plotting one wave, similarly have designed U graph, similarly T, S, and Q and P. So different pattern we can plot the we can derive the mathematical model and we can run MATLAB code, then we can execute it. Not only MATLAB, we can Python also, I can execute this code. So just let us see how this graph is going to look. So here I'm using the default values, ECG signal values. So default generally what is the standard is, we go for 70 seconds and P waves is having 0.25 and different timing durations we have P waves, amplitude, duration and time. And similarly for Q is also having this amplitude, duration and time, and QRS is also having the different values. So I have taken the default values, or else we can take we can choose our own choice to create a new database. But this case I'm taking one standard one. So here asking press if you want to go for default ECG. Yes, I want to go for default ECG. So just we are running this graph and you can see the graph of ECG. So in this case, we don't have any LEDs, any leads, or we don't have any ECG system. Still, we have derived the ECG data. So like that, you can derive the data and we can create a lot of the data. Then finally, you can do analysis before you design any system. So instead of directly go for system, you can first derive a mathematical model, obtain the simulation graphs, how the graph is going to obtain. Then after that, you analyze your model in simulation. Then after that, you can go for designing a IoT devices. Directly don't jump into the IoT devices for the any research application. So I think I was a little bit, I know I was running very fast last moment, but anyway, few topics I revised, I'll cover while discussing on 9th January. Yes, sir. Sai, sir.
Sir. Sir, I'll ask the participants if there are.
Yeah, you can have any questions, anything you can ask.
Right, respected participants can ask the question to the resource person for the topic.
I'll share all PPT as well as the documentation I'll share with you. MATLAB code also I'll share. You can execute your MATLAB in your system.
Sure, sir. Sure, sir. Respected participants or dear participants, can anyone? Right, if you have any doubts. Sir is ready to share. Dear participants, if you have any doubts for today's session.
Hello, sir.
Sir, Vijay,
yeah.
sir,
Yes, sir.
Hello, sir. Good afternoon, sir. I'm Devaskar.
Good afternoon, sir.
So a small question. Actually, nowadays we always hear about the security issues in IoT applications, and especially the topic you were discussing about this ECG machines in medical applications, sir. Can you please share with us, like, what are the security issues you may face in medical applications of IoT?
Okay. Yeah, I'll share. I think because I thought when I show this MATLAB derivation of this ECG, I thought 2 hours it is not practical, it's not completed. But anyway, I have other slides which is more detail about the applications. I'll incorporate those things and I'll share the updated PPT along with this derivation also, and MATLAB code also share with you.
Yes, sir.
Thank you, sir. Right, Raghu sir, I had a question for you, sir.
Okay.
Sir, coming to industrial applications, how economical the industrial applications could be in future? Coming to the applications of IoT in industry or industrial applications of IoT, how economically can be done.
That is what, maybe if you, when I was discussing about really IoT can be replace every problem. No, my answer is no. And whether it is economically, that is also it is a question mark. Generally, when you see the application, the demand, the incorporating the IoT and its application. So just I'll give one idea, one example. Like recently, I have developed one because under University we have weather station. We want to like in during summer because if you take a rooftops, because when you do garden garden farming or maybe roof farming they are doing. So during summer vacation, summer time, lack of water, most of these plants are drying. I mean they are dying. So whether we have any solution? Yes, we have a solution. That is one IoT solution where because you are going to the vacation and no one is pouring the water to the your plants. So what you can do is you can interconnect. You check the sensors of each monitoring. So it is economically, talk about economically, it is based on the application and based on the use cases. So for only for roof gardening, really I need to spend like 40,000-30,000 rupees. I say no, because that 40,000 I can get fresh plants instead of every year I maintain that system. So instead, what you can do is you can purchase new, if any trees are drying, you can do it. So that is a one case where IoT may not work. So it is like you have to see the feasibility. Really, it is essential, and whether it is scalable, and whether it is a benefitable, how much it is. I mean, at what extent it is going to be benefit. So I can't just tell that it is economically which application is exist, which is going to be more usable. No, until you are not implementing, understanding the problem and understanding the futures or expectations or outcomes. So we can't tell any economically, I can't say anything, but it is a continuous work. Take the problem, do the implementation. Then after that, you check it out whether it is useful or not. Then after that, you can continue. That is the reason many companies are the IoT companies. They are not startup companies. Then all companies are not sustaining. The reason they have come up with some idea, but that idea, the customers, end of the day, customers are customer need to be usage that one. Customer is not using, then if you design, if you incorporate IoT, then what is the use of it? Because I was talking about the refrigerator. When he purchases, he said, sorry, IoT devices, you can use it. But how many times have you used that IoT device? No, I didn't use it. Only rare cases. Maybe in 5 years, I may have used some 5 to 6 times. Then what is the usage of that application? Even when you purchase a car, we have n number of features, IoT features. Real are using all IoT features? No, we never use it. And for that, you have to pay 4 lakh rupees extra. So you have to take a decision whether it is really it is essential or not, whether it is required or not. Then you can design any model, or you can incorporate, or you can avoid those things. So it is all about use cases.
Okay, sir. Right. Sir, any participant, any doubt?
Okay, sir. I have an urgent meeting.
Okay, sir.
Yeah, sir.
Raghu, sir. Sir.
Thank you, sir,
for your valuable time and efforts in preparing and delivering the lecture, sir. The in-depth knowledge and the expertise truly enhanced the session, sir. Thank you, sir. We really appreciate you for your valuable time. Right? Thank you, sir.
Yeah. Thank you, sir. Thank you, sir. Raghu, sir. Thank you so much.
Thank you, sir.
Dear participants, we'll share you the feedback link and you are requested to submit the feedback link of today's session. Right? Thank you all the participants. Saida sir, thank you very much.
Yeah.
And all other participants from various colleges, thank you one and all. And
Thank you, sir.
we'll
Thank you, sir.
meet,
Right.
for the tomorrow session at 2 p.m. Thank you. Thank you one and all.